Working principle of LVP module. This is its internal schematic diagram. The core of the whole module is a 40A relay and an MCU. Parameters can be set by pressing buttons, and LEDs can display settings. We notice that this LED is smaller than other modules. This is a low-power design because this LED is rarely used after the parameters are set. The previous module only supports discharge mode, but this module supports both charging mode and discharge mode. So I will introduce the working principles of these two modes separately. 1. Discharge mode principle. Let's first look at the discharge mode. The discharge mode can be used to protect the battery and prevent battery damage caused by overdischarge. The basic connection diagram of the discharge mode is like this diagram. The MCU detects the voltage value of the connected battery through this path, and then compares it with the set high voltage threshold, CH, and low voltage threshold, CL, and then takes action. Refer to this table for the relationship between voltage and valve. In discharge mode, when the battery voltage is lower than CL, the relay will be disconnected, and when the battery voltage is higher than CH, it will be restored. If it is between CL and CH, the relay will remain in the previous state without switching. Interestingly, this LVP module has an automatic mode and manual mode switch. This switch controls the power supply to the MCU and other voltage monitoring circuits, including the LED. When switched to automatic mode A, this part of the circuit is short-circuited, and the entire MCU voltage monitoring module will always be powered, even if the relay is disconnected. This mode is the same as the traditional LVP, and there is always a standby current. Although the relay cuts off the load circuit current, this LVP module is always consuming power, and if it is left for a long time, it will also run out of battery power. But in automatic mode, even if this module will continue to consume power, this module is also designed with low power consumption. For example, the LED will automatically turn off after 1 minute. And after it turns off, pressing these buttons will automatically restore the display. When the switch 1 switch is switched to manual mode, this switch mode is open, and the entire circuit does not work. So the power consumption of the entire module is 0. When we press the S1 key, the current passes through S1 to power the MCU module, and the MCU module starts working, and then the MCU controls this switch to close, so that when we release S1, the circuit still works. When the voltage is detected to meet the relay disconnection condition, the MCU controls the switch to disconnect at the same time, so that the current consumption of the entire circuit is completely 0. But please note that in manual mode, after the voltage is restored, the relay cannot be automatically restored, and S1 needs to be manually pressed to restore. The automatic mode can be automatically restored. So they each have their own advantages and disadvantages, and you can choose according to your specific application scenario. Charging mode principle. The principle of charging mode is similar to that of discharging mode. For the connection diagram, refer to this figure. The charging mode will detect the electromagnetic voltage through this path. Note that this is different from the discharge mode. The principle of charging mode control is that when the battery is fully charged, the voltage will return to a relatively high value, and the voltage detection is used to determine whether to continue charging. If the voltage is higher than CH, the relay is disconnected to stop charging. The logic of the relay action refers to row 3 of this table. Now let's talk about the relationship between the actual voltage, high/low threshold, and relay working status in the 3 modes. As shown in this table, In the case of mode 1 and 2, it is a discharge mode when VCH, the relay, remains on. At this time, when the voltage V gradually decreases to CL, VCH, the relay is still on. Until it drops to VCL, the relay will switch to the relay off state, and then when V returns to CL, VCH again. The relay will remain in the relay off state until VCH will turn on. Note: Mode 1 is compared with Mode 2. Mode 1 has an additional force mode, referring to the first power on, when the actual voltage V is CL VCH. It will be forced to remain forced on. In the case of Mode 3, it is a charging mode when VCL, the relay, remains on. At this time, when the voltage V gradually rises to CL VCH, the relay is still on. Until it rises to VCH, the relay will switch to the relay off state, and then when V returns to CL VCH again, the relay will remain in the relay off state until VCL will turn on.